Good morning. Today we're going to be working on homework 1, using Excel to calculate the pressure in pounds force per square foot as a function of altitude, height, and feet for equation 8 for h in 1,000 foot intervals from 0 to 36,000 feet. Here is the formula as described. 2,116 times 1 minus 4.6618 times 10 to the minus 6 times height raised to the power of 7.765524 to calculate the pressure in pounds force per square foot. This Excel spreadsheet has already been created, and this is what we're going to recreate. The column A will be your height in feet in 1,000-foot increments, and column B will be the calculation of pressure based on the height in column A. Once columns A and B are completed with the height and the pressure, we can then create a graph that graphs the pressure in pounds force per square foot over altitude in feet. So let's begin. The first column is going to be the height in feet, and we're going to start with 0, and then for each subsequent cell we're going to add 1,000. Whenever you're adding a function in Excel, you start with the equal sign. If you do not, then it just treats your whatever you put in the cell as text. So we're going to want to create a formula, and the first thing to do to create a formula is start with the equal sign, and then you can click on a cell and it will take the value of that cell and you can manipulate it using arithmetic, and we're going to add 1,000. And now we have 0 plus 1,000 equals 1,000. And we can continue this function by just dragging down the cursor, and it will continue to add 1,000 to the previous cell until we get to 36,000 as described in the homework. So there you go. That's column A, which is going to be your height and feet. Now your column B is going to be a function, but it's going to be pressure. So we're going to label it using the correct label, and it's pounds force per square foot. And now what we'll need to do is go back to our homework assignment and look at the function. There are several ways to do this, so I'm going to describe 3 different ways of adding this function to the Excel spreadsheet so that it will take height, fill in the height, and calculate the resulting pressure. The first way is the most straightforward, but it's also the least preferred method because it's harder to change once you enter the values. But we're just going to directly put in the function. So we had the 2,116, and we're going to multiply that by 1 minus, and then I'll go back to the homework, 46618, and of course that's 10 to the minus 6. So 4.6618 times 10 minus 6. And we're going to want to multiply that by our value for h. And again, we're not going to directly enter the value of h because we always want it to be whatever is in the same row as the row we're calculating, but also in column A. So in this case it would be A2. And then we're going to raise that to the power of 7.765524. 7.765524, and that will give us that. And of course we knew that that was going to be the answer because we're multiplying a number times 0 and then we're subtracting 1 from it, which just returns a 1. 1 raised to any power is 1, and then 1 times 2116 is 2116. So we expected that value to just be 2116, no matter what the values of the different constants are. But we can drag this function down and see what the values are from 1,000 feet all the way to 36,000 feet, and that will be the pressure value. And if we go back to our previous spreadsheet, we can see that we start with 2116 as the pressure, and we go down to 508.09. So that is one method for calculating the pressure. Another method that might be a little bit more flexible is I'm going to add 2116 as a constant, and I'm also going to add the 4.6618 times 10 to the minus 6 as another constant. Let's see, and I think we'll need to put an equal sign here. And then we're also going to put what we raised this power to, which is 7.765524. And now we have the three constants. So we'll call this constant 1. We'll call this, constant 2, and constant 3. And now, instead of using this formula where the constants are already defined here, we can use the values of the cells. So instead of 2.116, I can replace that with this cell here. And I'll need to put dollar signs around it. I'll explain that later, but that's going to reference cell D2. This is going to reference cell E2. And this is going to reference cell F2. And you see that we got the same result, but now we have the ability to change the values that we put in there. And by that I mean that we can change this value here to 2000, and all of the resulting pressures will be recalculated using whatever is in cell D2. So again, we want to return to the actual value. But that is a better way of doing it, because the way that we had it before, no matter what values you put in, it would always calculate the function using the fixed values that you had, and it wasn't very flexible. This allows you to change around the constants and see different things. Okay, so that's the second method. The third method is a more advanced method, even than that, and that is no matter where you are, one cell or one grouping of cells can be named. And instead of calling that D2, we could call that constant 1. Instead of calling this E2, we could call it constant 2. And instead of this, we can call this constant 3 instead of F2. And now, instead of having the cell reference of D2, and by the way, if we didn't have the dollar signs here, then it would look for the next value because it's going to use the same row as the row that you're in. But these dollar signs fix that location at D2, no matter what the formula is. So that's why we had to put the dollar signs around it. If we did it where it didn't have the dollar sign, and I'll just give an example, we would get a problem if we tried to copy that cell because there's nothing in D3. So by fixing it at D2 with the dollar sign, we lock it to only that cell that has D2 in it. All right, so again, here's the formula. We're not putting the constants directly in the formula this time. We're putting the cell references. One third method can be replacing the cell reference with the name constant 1, constant 2, and constant 3. Oops, I must have spelled something wrong. Ha. This should be constant 1. Okay, so this is constant 1. This is constant 2, and this is constant 3. And now we have the formula, and we can just go down, copy down our formula. And again, it doesn't change the values in the cells, but it does make it a lot easier. Because again, if I need to change the value of this constant, it will automatically recalculate everything based on the new constant. Now the final thing we'll want to do is graph this. So we'll want to highlight both of the axes that we're going to have data for, and then go to graphing, which is under the insert function, and this is what we want, a scatter with lines as such. And now we have our graph. Of course, if we go back to the homework assignment, we were asked to plot shall have both title labels on both axes with correct units shown. So we're going to need to update the plot to change our title, and we're going to call it pressure versus altitude, and we can look for the chart titles. Let's see. Here we go. So we'll use the plus sign to add the titles. We've got the chart title, and then we need axis titles. So this is our pressure, pounds force per square foot, and this is our height or altitude in feet. Oops. And now the chart is complete. I hope this helps you understand how to complete the first part of the homework exercise.